Hello guys, thank you for being here. We are going to talk about Spot instances in AWS. At the beginning, the question, how many of you have any knowledge about this or experience or have used Spot instances? Okay, a lot of you, actually, that's good. We're gonna talk about the theory at the beginning, so some of the information you can find in the AWS documentation, which is pretty awesome, by the way. Some of them you will not find anymore because they are obsolete, maybe. They are the history or maybe something you will know only at the battlefield. So stay tuned. After the show, you are more than welcome to ask us a question because we have a lot of experience. We tried a lot of things, so we know what works and what doesn't. Okay, so let's start. First of all, this is how would AWS region in Poland, for example, look like. Why not? There is a lot of instance pools. By instance pool, I mean many instance type. AWS propose a lot of them. You can choose the standard one, the compute optimized, the memory optimized, and many others. It depends on you, how your application looks like, what they do. You can choose one of them. If you were the architect on AWS, what would you do to assure that everything works fine, and if the new customers want an instance, a server, you have one? AWS came with the pretty brilliant idea, not only them, because Google has something similar. It's called preemptive instances. They introduced something like Spot instances. Basically, it's a spare capacity. They have a lot of instances, a lot of servers, but on the other hand, it's a business, so they have to earn money. So what would you do not to lose anything, right? They came with the idea that they will give you the instance almost for free or very cheap if you compare it with the on-demand instances. But there is a drawback. We'll talk about this in a minute. Okay, so what's special about Spot instances? From the AWS perspective, if you look on the console, there is nothing. This is just the regular instance. The only thing, it's in the top right corner, it's a property called lifecycle. You can check if this is the normal on-demand instance, which you pay the regular price, or this is the Spot instance. And that's it. If you launch new instance, choose the Spot type. If you request the Spot instance, you will get one, probably. So let's say hello to Spot instances. There are two important information about them. First of all, it's cheap. It depends how cheap, because this is like the exchange, the stock exchange. If the price is right, you will get one, if your bid is right. If not, you will have to wait until the price is decreased. The second one is a drawback for you, and it's important. AWS can get your instance in 2 minutes. You will get the 2-minute notification, and that's it. Your instance is gone. Sorry, that's how it works. You have 3 ways to find out that your instance will be gone. The first one, you probably seen this on every instance. There is the metadata endpoint that you can hit from the instance, from application, why not? You will get the termination time. That's it, only the timestamp. The second one is API or command line interface describes Spot instance request. You will get the status, what's going on with your instance. If it's fulfilled, it's a normal status. That means it's up and running. Or if something is going not as you expected, that AWS is shutting down your instance, you will get the reason why. For example, instance is terminated by price, or capacity oversubscribed, meaning other guys probably needed it more. I mean, the new customer launched on-demand or a lot of on-demand, then AWS will give you the sufficient status. The third one is the latest way to check what's going on. It's CloudWatch event. You can redirect it, for example, to simple notification service and hit the endpoint, send an email, whatever you want. Here you will not, in the middle one, this one, you will not get the timestamp. Here you will not get the status or timestamp. You will get only the information if the instance is terminated, stopped, or hibernated. Okay, so how it looks like. If there is a shortage of on-demand, like here, AWS in advance will shut down some of spots just to make the buffer, so you as a customer who needs on-demand will not wait 2 minutes. So they shut down your instances in advance. On the other hand, if there is like the demand for on-demand, it's not that high, that probably most of the instances will be available as spots, and the price will be low. So this is good for you if you want to use spot instances. So spot instance requests. This is something like meta resource in AWS. You probably never hit this tab here, but what actually is a request? If you want to launch spot instance, you have to provide some information. The most important thing, it's max price, it's your bid price. How much are you willing to pay for 1 hour of spot instance? There is a couple of information. We don't have time to discuss all of them, so just read the manual. But we'll talk about some of them. The important thing here is this spot request, this example, is active, meaning that you got the instance, it's fulfilled. That meaning you get the instance again, and this is ID of the instance you have, and is managed and controlled by this spot request. By the way, by status or this hitting the API or CLI for spot request status, you are asking about this resource, not the instance. Okay, so if you open spot request, you have something like this. It's open. Your bid price is higher than market price, meaning you will get a spot request. So it looks like this. The spot pool is shortened by, for example, 2 instances, and the price will probably move up because there is less instances than it was before. If the AWS will close or you will cancel the spot request, the price will probably go down, the instance are going back to the pool, and other customers can get it. Okay, so what type of spot request we have? If you think about spot instance, you most likely think about this one. This is the standard one. You can get 1 or more spot instances, but they are controlled by this one, this spot request. This is the normal one. You go to the console, you hit launch or create new request, and you get this one. The second one, it's quite tricky because you will not get shut down for 1 to 6 hours. It depends on you. If you have the application which, for example, need just to compute something for 3 hours, you can try to create the spot block request, define how much time you need. It will be quite more expensive than this one, but you have the guarantee that you will not get shut down before the time is passed. The third one, the most interesting actually, it's something like auto-scaling group, but for spots. AWS created a native auto-scaling solution. It's this one. What's interesting here, it's many instance types. For example, you can have into one spot fleet request, you can have M5, why not C5 or not, or for example C5 X large or 4X large. It depends on you. You can define the weighting. It means you can define some parameter. It's important for you, like memory, storage, CPU, assign weights, and AWS will make sure that the requested capacity, the target capacity, according to the weights, will be provided, right? I mean, you can have in single spot fleet, you can have, for example, I don't know, 8 X large and 1 4X large instance type, and in sum, to sum up, it will have the capacity you wanted. Okay, so it looks like this. This is the spot fleet request. The fleet controls the single spot requests, and it has autoscaling. The autoscaling, it's similar to autoscaling group. You can define alarms, scaling policies, and you will get probably total capacity, target capacity. But since, I don't know, 6 months ago or something, they introduced also something like on-demand partition. You can define it in the spot fleet request, meaning it's your safe zone. The spot fleet request will control instances, spot instances, and on-demand in the same time, but the problem is you can only scale spots. So if you, like this one, set 2, it's similar to desired size in autoscaling group. If you do something like this, you will have 2 on-demand for the whole period when the spot fleet request is valid. Okay, so we are working with spot instances like more than 1 year or 1 year and a half or something. It not always was the same. 1 year ago, the prices could look like this. Actually, those are the real prices. We get them from the logs, just to show it to you. This line is on-demand price for C4 4X large. So this is quite expensive instance. But the prices of the spots had spikes, a lot of them. This is one of the interesting periods. Something happened in the AWS. This is US East 1, North Virginia, one of the zones. So something happened here, either the big demand for spots or something happened with the region, with the data center. We don't know, but in all cases, the prices will go up significantly. So if you hit the bid price, something like here, you will most often, you will lose your instance within hours, maybe. So it's up to you how much can you bid and how much can you pay in worst case scenario, and how important is for you the stability of your application. In the late November last year, AWS changed the pricing model. They flattened the prices, and from the beginning of the year, it looks like this. So no spikes, but there is a drawback about this, some trade-off. I will show you in the next slide. They changed the model of operating with spots. The prices are quite predictable, I guess. But either way, you can lose the instance, but in the other way. From the AWS console, you can hit the pricing history. The maximum period is 3 months. You will get all the zones assigned to you. And this is from the last 3 months. It's pretty flat, right? This one is significantly higher, but it's not the spikes like this. And it used to be like this. So, since we begin working with spots, the lowest price in 2017 was like really cheap. It was more than 20% of on-demands, so it was great. The highest one was like more than 10 times higher. So this is pretty ridiculous. This is the reason why people didn't use Spot too often. Since 2017, it's still quite cheap, but not as cheap as in the previous year. But on the other hand, the max price, it's still less than on demand, and much less than on demand. And since 3 months, more or less 3 months, the lowest price, it's quite high if you compare to this one. So the price are flat, but the price is higher. Okay, so 1 year ago, you could bid like the max bid you could place. It was 10 times as on demand, and a lot of people did this. That's why we had a lot of spikes, and the spikes was really high. Right now, the maximum bid price you can set, it's the same as on demand for this instance type. About prices, I already told you. 1 year ago, most of the interruptions, we had the status. This is the status, instance terminated by price. Now it's capacity oversubscribed, basically. AWS changed the billing model. You probably heard about this because they are in some kind of competition with Google platform. And Google had this for the long time, so they switched from 1 hour billing to 1 second billing. The problem is some of the companies was bidding for their instance to be shut down, because with 1 hour billing, the rule was if the AWS shut down your instance in the middle of the hour, the billing hour, you get the billing hour for free, right? So if it was shut down after 40 minutes, you get those 40 minutes for free. So some of the companies was trying to predict the price, the increase in price, just for example to have this compute power for 40 minutes, and they get it for free. Now it's basically impossible, because if AWS shut down after 40 minutes, you are billed for the 40 minutes. And this is this one. Okay, how can you get the Spot instance in the larger quantities? So Spot fleets 1 year ago, Spot fleets right now, and autoscaling group. You can get Spot instances in autoscaling group as well. The only difference is multiple instance type. In Spot request, it was easy and it was available from the beginning. In instance type, you can set only 1 instance type in the launch configuration. Fortunately, we didn't need this. For us, what was important, we had to scale on demand. And in Spot Fleet, it was never possible. Right now, you can have on demand in Spot Fleet, but you can't scale it. You can't change it. In autoscaling group, it's possible. That's why we decided that we will go with autoscaling groups, and Maciek will show you what we did.
Okay. So let me quickly tell you about how we operate in Codewise. So basically, we operate in AdTech business. There is like programmatic real-time bidding traffic. As you can see, it's hundreds of thousands of requests per second. And the deployment model is like we're using microservices. Here is an example of some of the architecture. As we can see, we have load balancers before the edge services, and then the services communicate directly using service discovery. And what you also see here is the zone affinity. So it's an important property of our services. First of all, because of latency. If you communicate only within an availability zone, it's faster and it's also cheaper, because AWS bills extra money for cross-zone transfer. So we need to sustain this situation. And our product, our tool for managing spots is called Spotty, and let me tell you how it works. So here were the assumptions that we were taking into consideration like beginning of last year. we wanted the solution to be simple, to be familiar to other developers. So we used existing infrastructure. All of the services were using auto-scaling groups. So that's why we did also with Spotty. We wanted to keep on-demands as a safe zone because, as you know, as you saw in the slides, the prices of spots were rapidly changing and we could lose them like instantly. So we needed this safe zone. We didn't want to save as much as possible. We wanted to save a lot, but to be safe in the process. And all the heavy lifting wanted to have on the AWS side. So here we can see how the happy path looks for Spotty. We have one on-demand group. We create a copy of it, as Jarek mentioned, only with setting the spot price. That means effectively this is a spot auto-scaling group. And here is one thing that we did. It's connected to this 1 hour billing that was at the time. If we already had an instance, so either way we would pay for a whole hour. That's why we waited till it worked at least like 50 minutes. We are checking if there are any instances available for migration. This means they worked over 50 minutes. We check, this is like also a safe bet. We don't only check if one zone is below, we check all of the zones. And we migrate to spot instance. Meaning, effectively, we're only manipulating the desired size of auto-scaling groups. This means auto-scaling group will launch 2 spots. When they are ready, when they respond with health check, we can decrease on demand and they will be gone. So basically, in this happy path, it's really a simple solution, but obviously we can lose the spots. So here is an animation that shows this. We are working with like 5 spots, and we can either our bid can be lower than the actual spot market price, or there's simple no availability of spots, and this is the most popular case right now. We get the notification, we need to react. So we're going the other way around. We're increasing on demand desired. The spots will launch. We're not killing them now because they will be gone either way in 2 minutes. And after 2 minutes, we just decrease desired in spots. So basically, it's really, really simple solution. So as I mentioned, the flow is to just copy the auto-scaling group and make one spot group out of it. So Spotty managed service consists of 2 auto-scaling groups, basically, the one for spots, the one for on-demands. It protects against spot shortages, because as we saw, if we get notified that we'll be terminated, then we increase on-demands. The important thing here is we don't use any database. Our persistence layer is AWS tags. So we include tags on auto-scaling groups, also sometimes on spot requests. So it is safe to restart Spotty, and we won't lose any state. This is basically what I told. And another benefit of it, we can do manual changes. We have an API, but we also can do it manually, just edit the tags, and Spotty will react. Here is an example of one of the services. As you can see, I needed to remove the sensitive names, but apparently the copied group is with spot suffix, also the spot suffix in launch configuration, and you can see that basically there are a couple of tags that are used, and this is all that is needed for Spotty to operate. Yeah, so everything seems simple and fun, but there obviously were some issues. And first one is I already mentioned that zone affinity for us is really critical. And what can happen with spots? So as we can see here, we are operating, for example, in 3 zones, and everything seems fine. But then we receive a notification in the whole zone. Maybe the spot price is up, or there's simply no capacity. So what will happen? We will obviously increase the on-demand desired capacity by 6, but the auto-scaling groups in AWS, their main goal is also to ensure a balance between zones. So what will happen? It will balance, but only within the on-demand. So now there's like just 3 instances in zone A, so there is big difference, and it actually happened quite a lot. As we can see here, within a couple of hours we lost whole capacity in 2 zones. As we can see in the top left-hand corner, auto-scaling group on demand kept the balance, but here we see the overall balance across the Spotty managed service, and we see that one zone contained significantly more instances, so we had an imbalance, and this was not the desired behavior. So, how we solved this? One of the way was to introduce something like aggregated services. Basically, instead of having just one spot group and one on-demand group, we divided them by availability zones. So effectively here, we had 6 auto-scaling groups, and they were all contained. This was one service, this was another service, and the third one, and they were aggregated. How it behaves now? So we also get the termination notification. We will increase the on-demand size in this group. That's why we are still keeping balance. Obviously, there's no spots here, but overall, it's perfectly balanced. Another way, when we divided it into multiple auto-scaling groups, they had defined different alarms. So it may happen that they will scale differently and will also lose the balance. That's why Spotty can manage between them and behaves like a regular auto-scaling group. Okay, zone affinity, I already mentioned why it's important. First of all, latency, but second of all, cost. It's also quite expensive. There's another example of thing that we did. Here's services that are using client-side load balancing for direct connection between microservices. And in this situation, everything is fine. Like we have, let's imagine this service is running on spot instances. All of the availability zones have the same capacity, so everything works fine. Like we basically have equal traffic amongst the zones. But what may happen? Like we may lose spots in 2 zones, as we saw in the example before. And now, these 2 services become overloaded because they are getting the same amount of traffic, whereas there's no capacity to handle this. And we introduced some custom load balancing rules. Actually, this was Netflix Ribbon, and we did it using also the service discovery. We compute, here's just some possible values, but basically we take into consideration the differences in amounts of instances. So the healthy zone will get a little bit more of the traffic, but we will not kill those 2 zones. So basically that's another thing that we did. Oh, second issue, the limits. So as Jarek already told, CloudWatch event notification about terminated spots were not available at the time of developing this solution. So we need to actually poll for the details of auto-scaling and for the details of spot instance requests. That's why if you manage a lot of services, you can hit the API calls limit. We introduced some caches in the middle, we worked it out. Also, the max number of resources. It might happen that you simply hit the maximum number of spot instances assigned to your account. Obviously, you can request to have it increased, but in the meantime, like your production doesn't scale, so keep in mind and be prepared. It's safer to like request for a lot of spot instances more, before. Also, the migration to new instance type is problematic because you might be tempted to move from C4 to C5, but keep in mind that the spot availability takes time. So they first launch only on demands, and just after a couple months, they may be available as spots. So if you were to simply move your launch, change your launch configuration to new instance type, you may happen that you won't be able to launch spot instances because they are simply not available. Another issue, like most services were stateless, they didn't care about the interruption. It was like regular scaling, like I can go down, I can go up, doesn't matter. But there are some services that do some heavy lifting, some processing, and if we know that we will be shut down in 2 minutes, then just don't take any more work. We will obviously launch another on demand. So we burned into the AMI also a simple tool that polls the local endpoint that Jarek mentioned. And if it detects that we are getting shut down, we just call our internal services manager in the AMI and tell the service to gracefully shut down. And what about scaling? So obviously scaling is really important to us because the traffic tends to have spikes and during the day. That's why we needed to come up with some solution regarding scaling. And how we did it is basically we copied the auto-scaling policies of the on-demands of the service that we are migrating to Spotty, but then, and this is a manual step because it depends on the service, we adjust the thresholds. So we can either want to be more cost effective, then we scale heavily on spots, effectively meaning like the thresholds for high CPU are lower on spot group, and it means the spots will launch first. But obviously they are also, you can do like safer setting to scale on demands. It depends. It really depends across the services, and we actually have 3 or 4 even behaviors implemented. It's really a matter of a service. And maybe let's talk now about how we actually use it.
Okay, one thing I want to add, you may are wondering why we are still using the old thing, which may change in the AWS, like CloudWatch events or 50 minutes of the working hour. We are still keeping it, but AWS changed the billing time to 1 second. We never know what will happen in the availability zone. So it may appear that everything is fine, but after 5 minutes, for example, the price or capacity is still or again not available, and we'll have to scale in on demands again. So for us, this 50 minutes that we kept right now, it was for the reason because we just wanted to avoid a lot of going left and right between spots and on demands. Usually the services like ours are not that are sensitive to moving from one zone to another because we have to wrap up, and some Java mechanisms have to be up and running for some quite time to get the best performance. So even if AWS was changing something, for us, not necessarily moving instantly to the new way of handling something was the best idea. Okay, the usage. We started with the first service here. It was like 1st of March 2017, so more than 1 year ago. We started without auto-scaling in spots, so we gradually increased it by hand. It is something like 6th here, 6th C4 4x large, and after 1 week we increased it again after tests and checking if everything is fine, Again, it was probably 12 here or something. In the same time, the on-demand spot group was lowered by auto-scaling policies, so it worked as we desired. Here is some noise, but this is the period of Easter last year. We wasn't sure how it will behave, if anything will happen while the whole company is away. So we shut it down here. After the Easter, we tried again. This again, probably 12 instances here, 24 here. And we hit some major fuck up during the processing. It was something unexpected. I don't remember exactly what happened because this is the application, other team application. So they decided that we need auto scaling in spots, and without it, we can't go further. So we stopped the spot instances. The on-demands went up, pretty much the same level as before. One iteration passed, we get the auto-scaling policies on spot group. It started to scale at the beginning, not that rapidly, but then we go with the full power of spots. It went up, and gradually the on-demands went lower and lower. After a few months, it stabilized at this level, and this is only the auto-scaling of spot group. So it was pretty awesome because we stayed safe with on-demands, but paying not that much, and everything was handled in the spot auto-scaling group, handled by AWS. How it looks like globally. This is the stacked graph. So it basically means that this one is pretty much equals this one, right? Because this is one after another. So the compute power at our company, it's more likely the same on spots as in on-demands, overall, globally in the whole company. So this is quite huge. The billing reduction, this is globally, it's 25%, but this is 25% compared to the reserved instances, because we have another tool. It's out of the scope of this presentation, but we are trying to cover as much as possible with reservations. So we have everything almost everything what's not on the spots, it's reserved. Without the reservations, we would have like, I don't know, 40, maybe 45% of bill reduction on EC2 if we consider only compute power, because as EC2, it's not only the compute power. The largest spot-based product, it's more than 50% on spots, and we have some of the product, meaning a lot of microservices. We had some microservices which are purely on spots. This screenshot with auto-scaling policies and the numbers, the thresholds, was one of them. Probably the biggest one, 33 spot large instances. This is 4x large on spots. So just imagine how much you can save if you do it right.
And they scale up to 72 instances.
Yeah. So. Okay, we are trying to make it open source. This is a Java application. It runs on T2 micro, so it doesn't need a lot. It just hit AWS API, checks what's going on, and decide what should be done if AWS is taking your instances. We don't have it yet. We'll have it in the couple of weeks probably, so soon. Just follow the GitHub organization. And that's it. Thank you.
So do you have any questions? Just raise your hand.
Thank you. My name is Pavel. I would like to ask you, how do you get information from AWS? So your application is currently still polling API, or you subscribing some events to be delivered to your
It's
application?
polling the
something?
API.
Same API and
Yep.
once per minute, or
Oh, like exactly, it's
5
within
seconds.
seconds.
5 seconds.
5 seconds.
It's in documentation. They actually they recommend doing it every 5 seconds, but polling the internal metadata endpoint for exact time. We are doing the same 5 seconds, but calling the API. So it's not exactly what AWS recommend, but still it's safe, right? Because either way, we have to know that something is going on. So if the exact time is available only from the instance, you will have to expose some endpoint so the instance knows what's happening, and then the Spotty is externally hitting the endpoint. It is possible, it's doable, but we tried something else.
And one more question. As far as I remember, there is some limit. You can't have more than 20 or 10, some number of instances in each VPC. So you have asked to extend this limitation for ahead before running?
Like 20 instances, it would be like not even one single service on test, I guess. So
It was something like you have 2 times of limits, right? First of all, it's how many resources you can have in a single VPC region or even availability zone, and the second one is API. How often can you call the API? We hit both of them, and probably we are hitting it still from time to time, and we have to increase it. Luckily for us, AWS has a great support. They increase it in the matter of days or hours sometimes. So right now in the single zone or single region, we have probably, 200 spots available for us. The one disclaimer, the limits are for instance type. So if you are going with the C4, for example, C4, probably the family is the important here. Then you want to switch to C5 because this is the newer one, and you know there are spots already. Then you have to issue the same ticket, support ticket, increase the limit for instances for the new family, and you will get it.
Does it cost you something, extending of limits?
No. I don't know how it's right now, but we had or have some kind of a support plan. I don't know which one and how many we pay for it, but it's quite fast for us. If this is the basic support, I don't know, but I believe it's pretty much the same.
Hi, I'm Wojciech. I have a quick question. Do you have any experience what's the availability of the Spot instances between various regions? We know that there are some small regions like Frankfurt, and they are bigger in Europe, at least, like Ireland. Do you have an experience?
like we're mostly operating with spots in North Virginia. This is US East 1. We do have something in Frankfurt. That's basically the 2 regions that we operate in right now.
Okay, and the
So,
US
to be honest,
huge,
we don't know.
So yeah, okay, thanks.
You can't know what are the number of spots or how they are utilized at this moment. There is a company which can predict something. It's from Israel. You can Google it. If they have a lot of customers, they may be able to predict if, for example, they are managing a couple of customers and all of them are getting down because they are using the same family of instances in the same regions. So they may know when the price is, let's put it other way. If, for example, their customer can want 100 instances and they know that someone launched 100 instances and the price was significantly higher, they may be able to know how many Spot instances are in this region. But for AWS, it's convenient that you don't know how many spots is there because you bid more, right?
Any more questions? No?
Hey, I'm Alex. So did you try to beat the spot market by requesting the older instance types in case the newer ones are not available? For instance, if you are running on M5s, try to request something like M4, IM3 in case there will be more spots for those instances. Would it be a good strategy?
Probably it would, but we didn't do this. Like our services are also highly tuned to the instance type, and the guys didn't want to have this overhead. So like we're learning, this service runs on, I don't know, M4 X large. We don't want it to be another option.
So essentially you have an instance type fixed for your service. The other question that I wanted to ask is whether you try to experiment with like different autoscaling groups, each autoscaling group taking one specific instance types in order to also cope with the case when there were too much demand for one instance types, but you can switch to the autoscale with another instance types in order to fulfill your slots that you need.
From what I remember, we didn't try this. We were considering doing something like separate launch configurations with different instance types and switching the launch configurations for one autoscaling group. So basically still one spot group, but we would be able to change the instance type like by changing launch configuration. But we didn't go with it.
All right, thank you.
Hello, I'm Andrzej. Sorry for my English. I've never learned this language, but I have one question. You used to measure auto scaling mechanism CPU usage. Now, when you path a security kernel, the CPU usage is wrong. It's totally wrong. It's many times this measure is not exactly what we see on the server. That's so. Do you have any other thing measure to scale auto scale?
No, we
mechanism?
don't have it. Since the beginning, we rely on AWS scaling policies, and we don't know if this is wrong or not. We are not checking by ourselves on the instance, what's the CPU usage. We use the scaling policy, and this is managed by AWS. If they are wrong, sorry.
Yeah, but actually the alarms and the scaling policies are defined by the creators of the service. So if they decided they want to scale according to the CPU, then our service, Spotty, is just copying it. We adjust the thresholds. If they scale by RAM or, I don't know, by disk usage, it's their case. It's just a simple CloudWatch. This is this CloudWatch monitor. You set an alarm and the scaling policy according to the alarm. So
yes, I know, but problem is from the money. When the CPU usage the wrong, yeah, your auto mechanism run the more instance, but you not have this instance at the time, so you spend the money for free for not usage. This is a big problem after a meltdown security path, and I thinking what you or many other people try to resolve this problem.
No, we didn't. No, we didn't. To be honest, we don't think. I don't think anyone tried it to solve somehow the company, because if you have one service with 30-something boxes, servers, and one is going crazy, maybe for most of the guys and the product teams, it's not that important. One of 30. So I know it's not sounds good right now, but if you decide to rely on AWS metrics, this is the trade-off. You have to take it. Either way, you are building something, your own solution, but we didn't try this.
Okay, thank you, answer.
Okay, guys, we don't have time for any more questions, so thank you.